Thank you for inviting me for this talk. So I'm going to share some of the results and slides and video we had during the last annular solar eclipse. And you already had that solar eclipse party here, right? How was that in Jacksonville? Yeah, crowd had. But in everywhere there was a lot of excitement, for solar eclipse. And the next one to be in April, so it will be more exciting. So let me show you my work. So our UNF team got the funding from NASA under part of the nationwide uh, Eclipse Ballooning Project. And in Florida, they selected two teams. So University of North Florida, Central Florida, and Florida International University. So Central Florida combined with us to make a one team and FIU another team. And in the Southeast region, we have eight teams, Southeast America. Sorry. On the way. Okay, so we launched two balloons. We give the name. One is Osprey to represent the Jacksonville, University of North Florida. And Disney, we represent Orlando, like a UCF team. But everything handled by our team. So we give the name Osprey and Disney. So we launched two balloons during the solar eclipse. Wait. So what's our objective? So this is a part of the engineering project. So we need to test with the balloon. We can send the balloon at high altitude, more than 26,000 meters or not. So earlier, what happened before reaching 26,000 meters, most of balloon pop up first. So they want to check whether we can cross 26,000 meters or not, or how much maximum we can go high. Second, to check the performance of the van and cut down unit. My research assistant Corey will explain you about that one. And to check the connectivity with the satellite during the flight and make a communication through the satellite or not. And to check other hardware like the radio frequency 900, Raspberry Pi camera, 360-degree camera, tracking, and our ground station antenna, grid antenna for connectivity. And also to check our ozone sensor payload to measure the ozone gas in the stratosphere. And then to share the data to NASA for the gravity wave study. So these are our main objectives during the annular solar eclipse. So we selected a location on a path of the annular solar eclipse, and we chose the Texas near San Antonio, a town named Pearson. And Pearson is about 1 hour drive on the west side, southwest of Texas, San Antonio, sorry. And Pearson is known for peanut. We're surprised to see this big. Let's say world largest peanut, some millions of pounds can go on annual. Wow. So our location is Pearsall, Texas, and we were there during October 12 to 15. And these are the different pictures taken by one of our colleagues on the Pearson, and I put in a line. So this is taken by the person from the ground, okay, not from the balloon. So you can see the totality rings nicely. So we launched 2 balloons. We call it one at Osprey, another Disney, and there are all the student team members. They inflated a balloon and put the different flight line payloads. I'm going to show you the video of the both one by one, and those videos are like a drone video. So how the balloon lift up, and so this balloon is about like a 16 pound, right, Corey?
Yes.
16-pound capacity.
Osprey was about 16,
Yeah.
and Disney was close to 7.
Yeah, so that's the upper limit. And to launch a balloon in a sky, it's not like a big balloon, ordinary balloon we live. No, we need to take a permission, right? So we took the permission from the Patel Aviation, and that's called the NOTAM. So NOTAM is a short form, Notice to Airmen. So we need to call them nearest radio, the airport control station, and they ask the question that from where you're launching, where you're going to terminate, what's the payload, all those details. They give one code. That's what they note of. And before launching, just 10 minutes before, we need to again call the ATC, air traffic control, hey, we are launching. And they say, okay, what's your note of? So we need to give, okay, this is the note of. And they will check everything, and then say, okay, final go, go. If they say wait, then we have to wait. If they say don't go, don't go. Stop, stop. So they have like a last minute control, because of the safety reasons. So everything done by the students, they communicate with air traffic control and FAA regulation and everything. So if you look the balloon, right, what we put on a balloon. So these are the different parts. We call the anatomy of the flight line. And everything is like a one box, and that's prepared by our students. Of course, they got the hardware from the NASA. The NASA supplied all the hardware, but they need to integrate, they need to assemble, they need to test everything. So top we say balloon. So we inflated balloon with helium gas, and that require about 1.5 tank helium to inflate the balloon. Then second one is the vent, valve, and cut down. That's our like a main heart of the balloon. And NASA wants to know how the vent valve operate and how it can be controlled. That's a big challenge. And that's one of our objectives. And Corey is going to explain you what is the vent valve and cut down function. So then I will go further.
Good evening, everyone. My name is Corey Barrett. Basically here for my class. One of the most important purposes of the actual flight line is that we need to achieve a float. If the whole point of the mission is to go up and reach a certain altitude and stay there. If not, the balloon will just go up and pop, which in this case is what happened during the flight. We had it and so the vent itself is the two-piece design. It has the neck, which attaches to the balloon side, and then it has the main body that has a servo motor. The servo motor gets received the signal. Then it's from the bottom. We start venting at about 67 to 68,000 feet to try and achieve the flow by 75 to 8,000 feet. Once we reach that target altitude, close the vent, and then we achieve our flow. You'll just float forever. You can't cut away. So the night before, we have predictions on the way the float would happen, ascent rate, and the cut down. Without those, you can't predict how. So you could theoretically just open the vent, break down, but you have no way of understanding where the balloon is going to go. So the night before, we run a prediction, and then we run our cut balloon prediction. So after a certain amount of time, we're floating, we get the data that we would like. We send a signal to the little circuit board that's in here that has a heating wire. And this heating wire, when we receive the signal, it just cuts away, and this neck falls off. The main flaw with this design is we have to send a signal up to a satellite to actually cut away and bend, and there has been problems with traffic on that satellite during the launch. There's a lot of schools doing this, so everyone's trying to bend at the same time. So I believe no one achieved a float during this. One thing that we all did gather was problems with the vent. Everyone had iterations, everyone had their own vent. One thing UNF was successful was we changed the design of the flap and the gasket. Other schools were having a lot of leaks with their vent. We had a successful vent that didn't leak, which is good news.
So although there's an issue of the leakage of the helium gas,
Yeah.
and because of that, the balloon not go ascend too much, it go going down.
Yeah, universities were achieving a negative ascent rate. They were descending instead of ascending as they were going up. So that was because of one of the previous pictures. You can see us inflating. There's a lot of time on the mat, so the balloon sits there for 45 minutes to an hour. So they're just sitting there losing feeling.
And this whole wall designed and fabricated in our lab by coding, by 3D.
We were coordinating with other universities as well, but yes, we did a lot of changes here.
Thank you. So after that is a parachute. It's a standard parachute, about 8 foot diameter parachute. And then the radar reflector, a simple golden color reflector. So any aircraft passing nearby or any helicopter passing by, they can reflect the signal that hey, something is going on here. And then we have a pterodactyl card. It's a pterodactyl card is a name, like a short name, but its function is computer collecting data. So it's a mini computer. It collects all sort of data like a GPS, temperature, pressure, accelerometer, everything. And then the next is the Iridium model. We call it a command unit. So with the Iridium unit, we can communicate through the satellite, and we can send the signal from our computer or from my phone also. There's an app, so I can send the command and it goes to satellite to the follower. And then next is the RFP 900. That's the radio frequency connecting with the ground station, particularly to broadcast the live video stream during the launch using the Raspberry Pi camera through the YouTube video. So we set up nicely. We got the connectivity with the ground station. We set the ground station about a few miles away on the path, but the wind changed the path. So balloon got a little bit diverted. So the connectivity with the antenna and balloon not established. So we're not able to make a live streaming of the video. But the RFP 900 also recorded 360-degree camera throughout the flight. I'm going to show you one of the video from the RFP 900 camera also. Then we have 360-degree camera, little high definition 360 camera that also recorded nicely all the videos during the flight. And then we have UNF payload, we call it the ozone sensor payload, that developed by two students named Nigul and Dustin Leonard. So they put a short name Niglio, and we made it first time and it worked nicely. And then we have another sensor payload. So first measure the ozone and second measure the reducing gas to make a counter check about the oxidizing gas. detecting correctly or wrong. So these are our flight line of the Osprey. Plus, command unit is also a tracking unit. So when the flight come down and terminate and come to the ground, with a tracking unit, we can track the location, and we can go and pick our payload. So these are some pictures, like all the students preparing the flight line a night before in a model. Then after launching, we were tracking the balloon in our van with a computer, and somewhere we sit down to look. So that's a picture. And after recovery, when terminate, and we got recovery of our flight line and busted balloon from the one of the area which is gated a ranch house something. We called them, and after 2 hours, the owner came and opened the gate, and we were able to get it. So this was our predicted path of the Osprey flight line in the 3D, and it worked well, except when it reached highest altitude, then it make a low. We anticipated it may come back towards the launch side, but it diverted on a left side, so it go this way. And this is another Disney flight. It was well also. So it goes like this way, and terminate here. And then while returning, we go by other way, come back other way. So mostly it follow our predicted path, but except in certain area, it not follow our predicted path. It changed because of the turbulence of the wind. And that makes hard for us to go here and there, left, right driving. And we measure the GPS data, altitude versus the time. So you can see the red color is the Osprey path, and the blue one is the Disney. And I put on the top this black color with a golden. So this is the ring. The black means during the totality time. So both the peak reach during the totality, but Osprey terminate early, while Disney go little longer by time. The reason is the Osprey is about 8 pound weight and Disney is about 5 pound weight. And Osprey reach about 30,000 meter, which is more than 26,000 over expected. And this one reach about more than 32,000, about 32,000 meters. So it crosses about 100,000 feet up. So that way our range will work well, if not leak. So it go highest altitude and then it burst. We also measure the pressure. And you can say as you go up, pressure decrease. So you can see that pressure decrease here. And then it start terminating, then it again increase and come to the ground. We measure the temperature, internal and external temperature. Internal of the payload and external of the payload for both the flight. So the first two is the yellow and gray is Osprey, but the lowest temperature Osprey measure about 0 degree. But Disney got more, about -70, because the Disney go more high and go further and stay longer time. And compared to external, internal is a higher temperature because of the thermal insulation of the payload body. But we can see that there is spike in a temperature about 10 degrees suddenly jump. at the time of totality. We also measure the humidity with the time during the pipeline, and you can see the humidity start decreasing and then again increasing, and we measure the UV light intensity, total UV light intensity index. So you can see during totality, the UV light index decreased to 0 almost, and both the end is small. Now, why we measure the UV light? Because we want to study the ozone. So ozone generated in the presence of UV light. So it breaks the oxygen into OO and combine with the O2 with O, make a O3 as a ozone, right? So we measure ozone concentration. We use our own developed gas sensor. Here the gas sensor is small hole is the gas sensor. It's a nanocrystalline thin film gas sensor we developed in our lab. It's our patented sensor, and we put the H sensor in a payload, and we found that at the highest peak, during this totality time, it start decreasing, ozone decreasing, and then it totally minimum at the peak, and then again it increasing. So this decrease of ozone because the UV light is not available to generate the ozone. Now this is in a stratosphere ozone, but this is in a higher altitude, right? But mostly in a ground ozone on the Earth surface, the ozone level little bit increase because of the smoke. But in a stratospheric ozone, it suddenly decrease, almost like a minimum. And we also measure the total white light during the totality, it's totally 0. So during totality, like a dark, no UV light, ozone decrease. And both the end periphery is maximum, again it increase. So that verify our science concept that generation of ozone is in the presence of UV light. More UV light generate more ozone gas during the daytime. And we confirmed this one with other flight. We made another flight a month before in our NASA flight. I'm going to show you that slide. So this is one month before we fly the balloon from the NASA. And that flight was a longer time, about 10-hour flight. We used this payload. And this is the payload in a stratosphere flying on a balloon. And this is a video picture of the payload. Yeah, the video camera. So here you can see that from the ground, the ozone increase as the altitude increase. And during the float, daytime, it keep increasing the ozone. And then at the night time, it start decreasing. So the night time, again, no UV light available, so it start decreasing ozone. And this is after termination of the flight, it comes down at the night. So we can say that both the balloon reached the target altitude. All hardware we successfully tested. We're not able to open the vent because or close the vent because we don't have. We sent the command to the Iridium, but Iridium was busy, and Iridium not execute the command. That's the only drawback in our whole flight. But that was a nationwide issue with everyone has faced the same thing. And even today we had a meeting and we had a discussion that maybe we got the less priority permission to use the satellite, something like that. So we need to pay more money to go expedite and like an express service to execute the command. So And again, we observed that ozone decreased during the eclipse time. That confirmed that there is no UV light available or drop in UV light. And this result will help us to make a further improvement for our next flight in April during total solar eclipse. And students work first time, so their confidence increased. Now they are all work as like an independent launch director. Each team member can handle independently entire flight line and launch and recovery record those information. I'm going to show you a video, couple of video. Uh, so first I'm going to show you the launch video and that video taken by drone. So you can see here the two colors. So this is the Osprey, this is the Disney. You can see how bad wind, whole flight line turned around.
We see our launch director forgetting his scissors.
He forgot to see that. See, that's a wind. So I was looking in my phone all the time to track the Iridium satellite. That's good. This one is a big building, is that jail, Texas jail. That's the Osprey. So Jack is a Douglas, and he's Michael. He's an astronomy professor from the Florida Gulf Coast. So both came as observer from NASA.
This
So both has a 360. One has a Raspberry Pi 360, and another this one is the Insta.
this one had super high definition.
Yeah.
Entire day. The upload the video. It was 128 gigs.
I'll show you 360 camera now. So this one is a Raspberry Pi camera. Now in a one footage, we can see the shadow on the earth coming down. Well, I was not knowing that one, that this is a shadow. I not believe that one, but one of the scientists told me that, oh, this is the what we are looking. And they put the same picture on their website. So then I realized that, okay, we also observe that. So in this one, this balloon going to pop. I'm going to show you that part. So I don't have any software right now to combine two in a one and make a one big. But I have the similar in another one. That software support that camera, but not this camera. So I cannot move 360 by my mouse, but you see it pops. Now you can see the speed increase coming down. Yeah, it's parachute. So those shadow, can you see dark? They say there's a shadow part, but this one is not well focused right now. Those dark. I'm going to show you another camera. I can take an horizon balloon, and some part you can see there is a part that you can see. In a very small portion of the video, we found like a gravity waves in a cloud formation. One of our friends' balloon, they got very nice gravity wave cloud. Can forward it a little bit fast. Let me change to another one. We are looking for one volunteer who can watch all the video. We didn't find the time. Okay, this is going to be pop in a couple of seconds. Pop. And this goes up to this was a property of one gas oil company. And we reach up to the gate, we trek up to the gate, but from inside the gate, there is about a mile. So we called the police, police came, police called and searched the address. Owner was not in Texas, he was sitting somewhere in California. And he gave the code for the lock to open the gate.
Is the power chute open to, prevent your equipment from getting damaged or?
I'll show you the, it work up to the person reached there.
Yes, it did work. It did work. Okay. Yeah. There was a team that it didn't work, theirs fell down. Destroyed.
See, when student reached there, back. Okay, the van came.
Probably, I'm sure it's pretty volatile. Once it got lower.
Now there's some angle and some time I got the shadow, but now I'm not able to. I can put the time, but I do not know which angle of the 360-degree camera I got the shadow on Earth somewhere. Okay, so these are all. I have like a whole bunch of about 40, 50 videos. And I have not time to watch each and every one. And I forgot to show you one more slide in a minute. That's important. So we did also small experiments, but we do not know about the results because it's not in our hand. It's called the soundscape. So NASA conducted one about 100-year-old experiments nationwide. So they distributed small electronic circuit, small card to those who are interested to become a volunteer. So they send us also. And we need to put that card 2 days before the solar eclipse and 2 days after solar eclipse. So we need to keep it about 4 or 5 days. And we need to tie somewhere outside of your building, house, maybe in a garden or yard or parking lot. So we tie on one of the tree here. So that record the sound of insect and bird. And they want to study that during the solar eclipse, certain insect sound or sound of okay, was going to be changed. So they want to do like a eclipse soundscape. We revisit an eclipse study from almost 100 years ago that showed that animals and insects are affected by solar eclipse. So what we need to do, we need to tie this way. After eclipse, after 2 days, we need to remove the memory card and send to NASA. And they will going to analyze the data. So I'm waiting for the results, what we recorded and what's the meaning of that sound. But that location has a very nice insect sound and bird sound that is go outside area. And they have special software which can filter out the automobile, vehicle sound, any person sound, and they can only pick the sound of the insect and birds and then make it. And they are also going to do during the next solar eclipse. And if you are interested to be a volunteer, you just go on a soundscape.org and you can log in, you can request them, they will send you free of charge the kit. And they will everything is inside like a self-address postage paid envelopes, you need to put your SD card and send it. And they will give you certificate. So if you have like a high school student, school student, most welcome. So he's my grandson, he participated for this one. Any. No. You can put, you need to, only thing you need to do, 2 things, you need to, where you put. So you need to search in a Google map your location. So you need to find out that latitude, longitude, right? And you need to give general description that like you are on a roadside or road is not there. So there are a couple of questions you need to just give tick mark. And take you everything, plastic bag, where the chip drive, everything, we just put it. And after 4 days, remove it and send that back.
It's good to attach it, I guess, to a tree.
I put on a tree because the bird can sit on that.
There and everybody's there, so better than put it on the pole.
It's really, they want more volunteers.
Yeah.
They're asking, anybody, we can put like a whole class, they will send the whole class. So we are highly grateful to NASA, NEPP, Florida Space Consortium, UNF, Dr. Hawaii also, he encouraged me a lot. So if you have any question, or Corey can give you answer, or I can give answer.
To repair thoughts at the lost site. Any other spot.
So annular solar eclipse is a path, right? Solar is a path. And we need to look at wind direction. So earlier we thought we were to launch from San Antonio. And we put the San Antonio, then wind direction was north. So as soon as we launch, we go out of the path. So we want to remain during our peak altitude, we want to remain under solar. So we go south. So all the time we will have those gas of path. What goes off, but even though we change, we call it rotation for east, but we are remaining in a lot of path. Yeah, so we have a iridium bottom and our iridium bottom. So iridium bottom is like a every step for the EMI number, right? The same as a bottom as a number. So we need to register, we need to pay the money for 1 year subscription. And people went there every 2 weeks, we need to go outside and make connectivity to check the connectivity, whether we get connectivity or not. And that was a really wonderful device. Even you walk one step, it records. We go one step off ether. Wonderful model. But to set the command, we need that technology is because they don't understand why they ask us to send an email. So command, we need to send by email. They have special email, so it automatically goes to server. So we need to put the command by email, it goes straight away to the email. And then it comes down to my model to execute my payload.
That's good, though. Maybe for stream accuracy of your locations.
Okay, so if you but simple tracker, GPS tracker, it go only like a corridor
Right.
on the ground, not in a hierarchy. But the area go from ground to all the way. That's more reliable. Measurement wise, more reliable. And not blocked by any electricity. Once you register, okay.
The Beach University, I mean, we email for the satellite. So like, UNF says a lot of traffic.
No, traffic for community sending command back to the payload. So at that time, we have about 200 teams in America.
Right.
So everybody is sending the command. And we are thinking that we are the low priority command subscription. So they would be great, you know. So I asked today that can we put an express plan that we can immediately without delay we can. Or we need to bypass that satellite and do our own search.
Everybody.
That gives idea to go further. So good thing for us that the students now have confidence to run their own way and they are starting the student up, the astronomy up, and they can go large. That's it.
Where will you launch from in April?
So we want to go India, but our Florida others wants to go to others or either walk. And some people want to go to south, is a Malwa, is a Malwa. That's also another part, but we don't want to go Arkansas because of the mountain range. We were looking for easy recovery. Because this one, the engineer was really not experienced, so it's a challenge, because the challenge. And well, Texas is a good road that we drive all the time. Because it's a road and drive and it's a stronger vehicle. We are ready for that, but we are stronger vehicle. Strong SUV. Luckily this time we have one today SUV, right? And there is a van. So van goes slowly, so you can see it. So good thing is the students learn more. That's a happiness. That's my satisfaction. They face all sort of a challenge. Nothing described, nothing given in a textbook or nothing that at a time, right? No lunch, no breakfast, anytime, just walk. You prepare. We got the results and we also. And top of that, we recover everything in a good condition. Well, something lost the camera, something was lost.
People couldn't get to the documents.
Yeah. Now, see, this is the first time we are doing, right? So some hardware we do not know at the beginning, but we know now where to buy and where to substitute and what to do. But balloon is not expensive. Helium gas is, you can say, we need to put about a one tank cost about $450. We have sitting down there $100. So we have 1.5 tank helium gas. Balloon costs about $200. There are about $100. Insta camera about $600. And then helium modem is little expensive. So you can say if you hold 5 times, if you hold material cost wise, maybe $10,000, $15,000. But the NASA pay top of the range each students $2,000 for eclipse. They give that garment, bottle. So annular eclipse is cheaper for us, but the total eclipse will be very expensive for us. Everything was double. The flight is double. Hotel double.
Because it's longer travel.
No, everybody wants to go in a total eclipse.
Okay, of course, the prices.
Yesterday I saw the rental car. No, not available. Certain location not available. Model, what is any model of this? $100 is here. Right? One flight I spent $1,000 to go to Little Dog. I can go to India $800.
Next close.
Yeah.
Okay, but after that, is there
I-
another soon or, okay,
But every lane is the big events
right,
compared to the annual. And that going to be still faster also because the totality is going to be about 5 days. And then, and hopefully there will be no weather issue.
I think this would be a key.
So that is a Monday, right? So we need to replace the UNF. Long back I will remember that we had a total eclipse and we keep the holiday. So this time Monday, we need to replace the day of it, like away, before starting the semester, keep holiday, and we can adjust that day only with any other time.
That's that in 2017.
Yeah, 27, right? Yeah, there.
But we read the doctor's.
Yeah. So this time also we can. So this time NASA is very serious to collect the data. Both things. They are very serious and they keep the meeting every month and every other Friday we have physical meetings and coordinate. Like a whole Friday my gone in the meeting. And they want like a report and data and then they receive it immediately help us. So this time they are going to study now. And right now they said today they give us one update. How to calculate the gravity wave wavelength. We don't have software. That's a theory, but we don't have software. But we'll try.
Well, maybe we should all thank Dr. Patel and thank you very much for